Good day, Power 5 AP Math students. We are carrying on with complex numbers, and you should have your Argand diagram worksheet in front of you. I apologize that they're not typed, but their time is tight, and we are working 14-hour days, so it is just difficult to get everything absolutely perfectly. You do not have to print the notes. You can just save them and print them out when you get back to school, and you can just write some key ideas down when you're watching the video. I understand that some of you don't have printers, so just take down some key ideas and save the document and print it when we get back to school. A big thanks to our 3 studio guests today and for giving up their time and charging a mere 1,000 Rand an hour. First of all, to Pila, welcome. She specializes in complex numbers. And all the way from Italy, we have Bella. Welcome, Bella. And last, but by no means least, we have Jemana. Welcome. And thank you to all of these complex number specialists who've come in and helping us today. We are truly indebted. Right, let us share screen and okay, right. So in order to understand, we're going to represent complex numbers as an Argand diagram. You're not going to know what I'm talking about yet. Okay, so this says, for those who can't read, representing complex numbers on the complex plane or the Argand plane. Okay, but in order to do this, we need to have a quick crash course in trig on the Cartesian plane. Okay, and this will serve you in good stead because you are going to do this trig again in core maths, so you'll look very sharp. Okay, if you know what's going on before then. So up to now, you've only worked in trig, a right angle triangle trig. Okay, and in right angle triangles, if you remember, if we had some angle theta in a right angle triangle, then we would call this side over here the opposite side, this side over here the adjacent side, and that side over there the hypotenuse. Actually, I'm not even sure if you've done this a little bit, but anyway, let's give it a go. So anyway, all trig is in right angle triangles, we use that definition. Sine is the ratio of the opposite side over the hypotenuse. You don't have to worry about this one here. Cos is the ratio of the adjacent over the hypotenuse, and tan is the ratio of the opposite over the adjacent. You will do that, but in core, all that you need to understand at the moment is trig on the Cartesian plane. Okay, so don't worry about that for now. Okay, but do worry about this for now. So on the Cartesian plane, okay, and you've got an x-axis, remember the origin, just like you did in grade 1, the y-axis, and then you can plot points where x is how far you've gone across, y is how far you've gone up or down. Okay, and trig is actually a very simple concept. Okay, it seems complicated because there's all these strange words in it, but it's actually not so bad. So let's say we took this yellow point over here, the point 4,3. What does that mean? It means we've gone 4 across and we've gone 3 up. Okay, so that distance up would be 3, that distance across would be 4. Now, if I've got a right angle triangle where I've got 4 across and 3 up, how do I find that distance over there? Okay, Pila, how are you going to do that? Yes, by Pythagoras. Okay, and what we're going to say is if this is your x value and that's your y value, and we're going to call, so this distance across is my x coordinate, this distance up is my y coordinate. If that's a 0.43, my x value I've gone 4 to the right, my y value I've gone 3 up. Okay, and to find the radius, okay, we're going to say this side squared, this distance over here from the center to the origin, I'm going to call my radius. Okay, the distance from the center, from the origin to the point is your radius. Okay, from the origin to the point is called your radius. Right. So now to find this, and I'll give it the symbol r, that value r, what can we say? We can say I've called this particular one r1. we're going to say r, using Pythagoras, is equal to x squared plus y squared. So r is equal to 4 squared plus 3 squared, which is 25. Sorry, r squared is equal to x squared plus y squared. So r squared is equal to 4 squared plus 3 squared. So r squared, I've called it r1, you can just call it r if you want, is going to be 25. And r can't be negative, so r is going to be the square root of 25. So my radius is 5. So this distance from the center to the origin, from the origin to the point, we call your radius. From the origin to the point, that thing over there is called your radius. If you're given x and y, you know that and you know that, so you've got a right angle triangle. You don't have to draw the right angle triangle in. It will always follow that x squared, this formula is going to be important, x squared plus y squared, in other words, an x coordinate squared plus a y coordinate squared will be equal to a radius squared, okay, because of Pythagoras. So now in that yellow triangle, I've got r1 is equal to 5. So I've got a triangle which is 3, 4, and 5, right? Like that. So my radius is 5, my y coordinate is 3, and my x value is 4. Okay. On the Cartesian plane, okay, we start to look at angles. And an angle on the Cartesian plane is measured in an anti-clockwise direction. So this is just a Greek letter of the alphabet. Okay, we spell it theta, Theta. You may have come across it before. It's just a letter of the Greek alphabet, and it's a common notation to use a Greek letter when we're representing angles. I'm sure you've come across it in geometry before. On the Cartesian plane, an angle is measured from the positive x-axis, in other words, from this side, in an anti-clockwise direction. That's how we define an angle. And this starting point over here is 0 degrees. Yeah. Just make sure this is in focus. And we move in an anti-clockwise direction. So that would be 90 degrees. We carry on going. That would be 180 degrees, 270 degrees, 360 degrees. There's quite a lot that you're taking in here. Don't panic if you don't get it first time around. You will go over a lot of the stuff in core again. Okay. So an angle on the Cartesian plane we measure in an anti-clockwise direction. But you are AP students, so you need to struggle a little bit. Okay. Don't just say, oh, it's hard, I can't do it. It's too difficult. I'm going to phone my mom. Okay, try, engage. Okay. So a reminder, on the Cartesian plane, just like you always use, a point x, y tells you how far you've gone across, x, y tells you how far you've gone up or down. You've done that in grade 9. The distance from the origin to the point we call the radius. To find the radius, because of Pythag, you can remember this formula, the radius squared, the distance from the center to the point, okay, from the origin to the point that we're working with, will always, radius squared will be equal to x squared plus y squared. You can then go find your radius, the distance from there to there, from your x and y coordinates. Okay, that's pretty important. Then we're going to talk about an angle on the Cartesian plane, and an angle on the Cartesian plane has direction and a starting point. The starting point is the positive x-axis. How do you measure it? Anti-clockwise direction. This is 0 degrees over here. So it'll be 90, 180, 270, 360. Okay, later on you'll see we can keep going. The good news is we're only going to be working with angles between 0 and 90 degrees. In other words, we're going to be working in quadrant 1 of the Cartesian plane only. Okay. Right. So now this idea of trig. Okay. Trig is simply ratios. It's quite intuitive. Okay. The names are the things that confuse you. Okay, and all trig is, it's a naming of ratios. And we're going to use x coordinates, y coordinates, and radiuses for a specific point and an angle. So if I take this fixed angle here, and this angle stays fixed, and I extend this line from 4, 3 outwards, okay, intuitively, okay, if I say to you now that this distance here is 8, up to here, it was 4. From here to here, okay, the x coordinate is 8 in the pink triangle. So here in that distance from there to there is 8. Okay, so I have doubled the distance across. Okay, I've kept the same angle. That's really important. along that same angle. Everywhere I'm working along the same angle, this angle theta, right? If I extend this, so I've got 4 over there, if I extend it some more, okay, I've doubled this distance, 8, right? So I've doubled that distance. So every other distance is also going to double. The horizontal distance has been doubled, so the vertical distance has been doubled. What was the vertical distance? Well, the vertical distance was 3, because the y-coordinate was 3. So the horizontal distance has been doubled, so the vertical distance has been doubled. So that distance there will now be 6. I've times it by 2. Okay, so this point over here will be the point 86, right? Okay, you're welcome to go measure these things. Okay, start off with an accurate 4-3, draw a line through it, and measure these things over there. Likewise, so I've doubled that, I've doubled that. The radius will also double in moving from one point to the other. So this initial radius was 5. The radius is what? The distance from the center to the point. The new radius will be double that. 5 times 2 is 10, right? Okay, so that's that over there. Right, I want you to pause the video, and this point over here is 400. Okay, it's not infinity. Excuse my handwriting, Mrs. Croftley's class. That's 400, right? Okay, so now I said to you, you stayed on this line, and let's work with this original triangle. What did I do in this other one in the pink triangle? I said from 4 to 8 I times by 2, so everything else I times by 2. So say to yourself, what did I times 4 by? The distance across has changed from 4 to, obviously it's not to scale on the diagram, to 400. So ask yourself, what have I times the distance across by? What did I times 4 by to get to 400? Okay, so using that logic, I want you to go write on the y-coordinate at this point over here, and I want you to write this radius over here. Go figure that out. Okay, so Bella, what did you times 4 by to get to 400? By 100, right? Okay, so I times the x-coordinate by 100. I must times, if I'm on the same line, I must times the y-coordinate by 100. So 3 times 100 is 300. So that point, okay, is going to be 400, 300. As I say, you're welcome to go do an experiment and measure these things. Okay, I'm on the same angle over here. The radius, so I times the x. To get from yellow to green, I'm timesing by 100. So that was 5. So the new radius, well, 5 times 100 will be 500. Okay, so those are your points. So the key trick now, trig is what? Trig is the naming of ratios for a fixed angle. Okay, because your ratios for a fixed angle, we're going to explain this to you now. For a fixed angle, your ratios are going to stay the same. So if I now go, okay, let's move this down a bit and refocus it. Okay, so this says over here, if you can't read my writing, listen, the ratio of the y-coordinate over the radius for angle theta. I'll say that again, and you can neaten it up. The ratio of the y-coordinate over the radius for the angle theta. So for this angle theta, and this logic works for any particularly sized angle, as long as you're working with points on the same line, okay, on this with the same angle. So for a fixed angle, no matter where you are, your ratios, okay, for x-coordinate, y-coordinate, and radius are going to stay the same. So I'm looking here now at the ratio of the y-coordinates over the radius on this line. So if I take the yellow point, Jemana, what's the y-coordinates? Okay, the y-coordinate is 3, and the radius is 5. Okay, so that's equal to, if I'm using the yellow point for this angle theta, the ratio will be the y-coordinate over the radius will be 3 over 5. If I go to the pink point over here, okay, what is going to be the ratio of the y-coordinate over the radius, please, Bella? Well, the y-coordinate is 6. The radius is 10. So it's 6 over 10. Okay, and that should be intuitively, it should make sense. Okay, that those ratios are going to stay fixed. Right. Now, if I go look at the green triangle over here, Jemana, what's the y-coordinate there? Well, it's 300. Okay, and the radius is 500. Now, if you simplify all of those ratios, Okay, the simplified answer for all of them, 6 over 10 simplifies to 3 over 5. 300 over 500 in the simplified form is 3 over 5. So anywhere, if I take any point on this line, okay, for some angle theta, if I'm working with an angle theta, the ratios anywhere on for this angle of the y-coordinate over the radius will stay fixed, right? And that's going to be a really powerful tool in math, the fact that those ratios stay fixed. So instead of every single time saying that the ratio of the y-coordinate over the radius for this particular angle theta is 3 over 5, that's clumsy. Okay, to say that every single time in math. Math is about making life eloquent. So just like we don't say the girl in my class is always crying, okay, because it'll be exhausting to say that. We give her a name. So when we're talking about that, it's simple. So we say Kyra, right? So that's how we're going to do it. Okay. So the name that the Greeks gave to this ratio, okay, of the y-coordinate over the radius, okay, the ratio of the y-coordinate over the radius, okay, was given the name sine theta, right? So sine means the ratio of the y-coordinate over the radius for a particular angle. If you change the size of the angle, the ratios change. Okay, so sine theta, the definition of sine is that sine theta is equal to your y-coordinate, the ratio of your y-coordinate over your radius. It's just a name. Okay, it's a name we give to things to make our lives easier. As I say, instead of every single time saying the ratio of the y-coordinate over the radius is equal to 3 over 5, we say sine of theta is equal to 3 over 5. So don't let Trig bully you. So in this particular case, instead of saying this whole sentence, the ratio of the y-coordinate over the radius for angle theta is equal to 3 over 5. Instead of saying that whole long spiel, we're going to say that sine theta is equal to 3 over 5. That is exactly the same meaning as this whole sentence over here. The ratio of the y-coordinate over the radius for this particular angle, okay, is 3 over 5. Instead, we say sine theta is equal to 3 over 5. So sine is the ratio of the y-coordinate over the radius. Now, get out your calculators. Okay. If I get my calculator, which I've got to go get, okay, and I now want to go find that angle. To find an angle, okay, what you're going to do is you're going to go shift sine to the -1. Okay, that's what I use to find an angle. So my calculator, I'm going to go sine to the -1. So I'm going to go shift sine to the -1. Sugar. Okay, I'm working over here. So to find the angle, so I want to know now what is the actual size of that angle. My calculator lets me do that. If I go shift sine to the -1 of what's that? Sine theta. So I'm trying to solve this on my calculator. What angle will give me a ratio of the y-coordinate of 3 over 5? So I go shift sine to the -1 of 3 over 5. Okay. So my calculator, shift, let me do that again. Shift sine to the -1 of 3 divided by 5, close brackets, equal, and let's do it to 2 decimal places. Okay, so it'll be 36,87 degrees. That's going to be the size of angle theta, okay, over there. And if you're given an angle, okay, when I go work out, so now I'm claiming that if I go work out sine of 36,87, it should be 3 over 5, which is 6 over 10, which is 0,6. So if you're given the angle, you don't press sine to the -1, you just press sine of 36.87. Okay, what I'm going to rather use actually is my answer button, because that'll give all the decimal places. Okay, sine of 36.87, and what do you get? You get 3 over 5. Okay, so when you've got an angle, you press sine. So sine of 36.87 gives me a ratio of 3 over 5. Okay, right. Now, okay. So that's the name. So what is sine? It's the name of the ratio of the y-coordinate over the radius for a particular angle. I know it's quite a lot to take in. Just calm the farm. Right. Okay. Now, just like the ratio of the y-coordinate over the radius stays fixed for an angle, okay, likewise, if I look at the ratio of an x-coordinate over the radius for a fixed angle, okay, that ratio is also going to stay fixed. So let's have a look at the ratio of the x-coordinate over the radius. So if I go to the yellow triangle, okay, at this point over here, Pilar, what's the x-coordinate? Okay, because I'm looking at the ratio of the x-coordinate over the radius. Well, the x-coordinate is 4 and the radius is 5, so it's 4 over 5. If I stay on that line and I go to this point, what's the x-coordinate over the radius going to be? Well, it's going to be 8 over 10. Okay, and Bella, if I go to this point over here, what's the x-coordinate over the radius? X-coordinate over the radius is going to be equal to 400 over 500. Sorry, this was in a pink triangle. This is in the green triangle. Okay, right. So, in other words, these ratios are fixed because 400 over 500 simplifies to 4 over 5. 8 over 10 simplifies to 4 over 5. So I can say that for this diagram, for this angle theta, the ratio of the x-coordinate over the radius for any point on this line, okay, will be fixed. And it will be fixed at 4 over 5. Now, just like the Greeks named the ratio of the y-coordinate over the radius sine, they gave a name to the ratio of the x-coordinate over the radius for any fixed angle. And the name they gave that child was cos. So cos of that angle, okay, so cos for our angle theta in this diagram over here, okay, is going to be equal to what? Well, it's going to be equal to x over r, which was 4 over 5. I'm going to do one more like this with you. I'm going to do it by yourself, okay? Right, so now what? Okay, then I'm going to say, alrighty, okay, I want to go find this angle. Now we know, okay, from the previous question, so just a reminder, sorry, cos is the ratio, sine is the name for the ratio of a y-coordinate over the radius, cos is the name for the ratio of an x-coordinate over the radius. Okay, cos is the ratio of your x-coordinate over your radius. I'll give you a way you can remember that now. Okay, right. So in this particular diagram over here, I know that cos theta is equal to 4 over 5. All that's saying is that the ratio of the x-coordinate over the radius is 4 over 5. Now, if I was given that information, how do I find that angle? Well, when I was told sine theta was equal to 3 over 5, how did I find that angle? I went shift sine to the negative 1 of 3 over 5. So here, I'm going to go shift cos to the negative 1 of 4 over 5. And we don't get the same angle, 36,87. I'll buy you all lunch. So I'm going to go shift cos to the negative 1. Cos to the negative 1 finds the angle. And if I go cos to the negative 1 of what? Of 4 divided by 5 equals, voila, I don't know your lunch. Okay, you can't see that. And your answer is 36,87 degrees. Okay, so theta is equal to 36,87 degrees, which is the same as that. In other words, if I went cos of this angle, okay, cos of that 36, if I went cos of 36,87, okay, cos of 36,87, okay, should give me the ratio of x over r. So if I go cos of answer, I get 4 over 5, which is that ratio which I wanted, which is 36,87. Okay, right. So now, the last ratio. So the Greeks named their first child, which is the ratio of the y-coordinate over radius for a particular angle, okay, as sine. Their second child, they looked at it and they thought, oh, you're a lovely ratio of the x-coordinates over the radius. What are we going to call you, my son or my daughter? We're going to call you cos. I'm not sure, or whatever between. I don't know. Right. And the last child they had, okay, was the ratio of the y-coordinate over the x-coordinate for a fixed angle. Okay. So in our diagram, for this example, okay, if I look at the ratio of the y-coordinate over the x-coordinate along this whole line, that should stay fixed. Okay. And if we look at the yellow triangle, the y coordinate over the x coordinate is going to be 3 over 4. Okay. And if I look at the pink triangle, the y coordinate over the radius is going to be 6 over 8. Okay. And if I look at the green triangle, the y coordinate over the radius is 300 over 400. All of those simplify to 3 over 4. So we know that the ratio of the y coordinate over the x coordinate for this angle theta is equal to 3 over 4. Now the name they gave to that child, okay, the y coordinate over the x coordinate is tan of an angle. So tan theta is the ratio of the y, just like y coordinate over the x coordinate for that particular angle. So tan theta is the ratio of a y coordinate over the x coordinate for a particular angle. Right. So in this case, tan theta we said was equal to 3 over 4. Okay. Again, if I'm given a trig ratio, how do I find the angle? To find the angle, I'm going to go shift, let's do it here, angle, I'm going to go shift tan to the negative 1 of 3 over 4, right? So my calculator, I'm going to go shift tan to the negative 1 of 3 divided by 4, and I get 36,87 degrees, which is the same as we've got every single time. Again, if I now go the other direction and I say tan of my answer 36,87, you should get an answer of 3 over 4, and I do. Okay, it's quite a bit to take in. Okay, so the ratio of the y coordinate to the radius was named sine for an angle. For a fixed angle, the ratio of the x coordinate over the radius is named cos. Okay, for a fixed angle, the ratio of the y coordinate over the x coordinate is called tan, sine. Okay, and if I go over here, so say, let's just do 2 examples here, and say we have, okay, let's just fix it up a bit. Okay, so we have, whoa, sorry about that. So come on, oh, what a balls up. Sorry, I just took a photo by mistake. Okay, right. So autofocus. Right. So let's have an example. So the way I remember it is a silly little poem you can use, which says, "Shade, think of somebody lying in the sun with their butt out." Okay, and then you go up to them and you say, "Think of whatever you like." Okay, whatever tickles your fancy, and you go, "Right, Miss, Mrs., Mr., whoever you are, Miss, shade your rear." And they say, "But why?" "Because X-rays tan your exterior." Really lame, but it can help you. Remember that sine is the ratio of the y coordinate over the radius, right? Okay. Cos is going to be, sorry, we should go over here. So shade your rear. So in other words, sine of an angle is the ratio of the y coordinate over the radius anywhere along that line. Remember, if I extend the line, okay, and I have another point x, y, and r, those ratios, we call that x1, y1, and r1, those ratios would stay fixed. So y over here, r would be the same thing as y over r there, or over there, or over there, or over there. That ratio for that angle stays fixed. Trig is about naming ratios. So sine of angle theta would be the y coordinate over the radius. Shade your rear. Sine is y over r. Why must you shade your rear? Because x-rays, in other words, cos is the ratio of the x coordinates over the radius, because x-rays tan your exterior. Okay, tan your exterior. So tan is the name given to the ratio of the y coordinate over the x coordinate. Okay, so let's just do, I'm going to add in a little practice here. Okay, and let's say I had, so use 5, 12, 13. Let's just call it Okay, let's just do hang on. Let's what's the other one? 5, 12, 13. Okay, don't worry. Okay, right, let's just have a look at this. Okay, example 1. Okay, determine the value of cos theta, sine theta, and tan theta for this diagram. So what's going on in this diagram, okay, is you've got the point 2, 3, right? Now, in order to work out cos, sine, and tan, you need what? Okay, there are your definitions. To work out cos and sine, you're going to need your radius. What is your radius? Your radius is that distance over there, okay? And what have I got? Well, if you drop a line here, you can think that you've got a right-angled triangle where x, you don't have to draw this right-angled triangle in it, by the way. The distance across is x, the distance up is y, right? Your x-coordinate tells you how far you've gone across, your y-coordinate tells you how far you've gone up and down. So in that particular diagram, in every diagram over here on the Cartesian plane, it'll always follow, and just remember this, x squared plus the x-coordinate squared plus the y-coordinate squared will always be equal to your radius squared, where your radius is your distance from the origin to the point that you're working with. So in other words, in this particular case, 2 squared plus 3 squared is going to be equal to r squared. And they're going to get 4 plus 9, which is 13 is equal to r squared. Okay, so the square root of 13, and we say this is called third form, and we're always going to leave things in third form in trig. Okay, so your radius in this particular case is root 13. Okay, so I've got x's coordinate is 2, the y coordinate is 3, and the radius is equal to root 13. Now remember, if let's say you double this distance, okay, then your new x coordinate would be 4, your y coordinate would be 6, I'm timesing by 2, and your new radius would be 2 root 13. Okay, so your new radius would be 2 root 13. Okay, your new x coordinate would be 4, your new y coordinate would be 6. Okay, so the important thing to realize is that this line, you can take any point along this line and those ratios are going to stay fixed. Okay, we only needed 1, but I just want you to be very clear in your head. It doesn't have to be that specific point on the line. It can be anywhere on that line. Okay, so I'm going to use both things. So if I said to you now, go find for question 1, what is cos theta equal to? Well, all that means is what is the ratio of the x coordinate over the radius. So the x coordinate for this angle theta is the yellow one, which is 2. So you could write 2 over root 13, or you could write, if you chose that point, 4 over 2 root 13. And if you divide the top and the bottom by 2, you get back to that, obviously. So cos theta, okay, there were your x values, because cos is equal to the x coordinate over the radius. Okay, so it would be equal to, your radius is in pink. There's your radius, there's your x coordinate. So cos theta is equal to 2 over root 13. Right, then if I said to you, for this particular diagram, what's the value of sine theta? Okay, well, for that angle, sine is the ratio of what? Okay, sine is the ratio of the y coordinate over the radius along that, for that particular angle. So what's your y coordinate? Well, I could use 3, okay, and if I use 3 over here, the radius is root 13, and if I use 6 over there, the radius is 2 root 13. Okay, so sine, okay, that'll simplify to 3 over root 13. So we say sine theta, you only have to write 1 down, the simplified version. So sine theta is equal to 3 over root 13, cos theta is equal to 2 over root 13, and last of all, tan theta would be equal to the y coordinate over the x coordinate. That's the definition of tan. What's the ratio of the y coordinate over the x coordinate? Okay, sorry, the y coordinates were in green, the radiuses were in red, and the x coordinates, the y coordinate over the x coordinate is going to be green over yellow. So if I use this one over here, it's going to be 6. This one over here, the y coordinate is 3. The radius is tan is equal to the y coordinate over the x coordinate. The y coordinate is 3. The x coordinate is 2. Okay, and if I go use this one over here, it's going to be 6 over 4, which is the same thing. So tan theta is equal to 3 over 2. So for this diagram, cos theta is 2 over root 13, sin theta is 3 over root 13, and tan theta is equal to 3 over 2. Right, and the last question here says, go find the angle. Determine angle theta correct to 2 decimal digits. So I can use any one of these things. So I could use the fact that cos theta is equal to 2 over root 13. How would I find the angle? I'd go shift cos to the negative 1 of what? 2 over root 13. And cos to the negative 1 of 2 over root 13, is equal to what? And you get 56,31 degrees. 52, right. But say you decided, so that was using cos is equal to 2 over root 13, but I could also use sine is equal to 3 over root 13. What would I do then? I'd go shift sine to the negative 1 of 3 over root 13 and shift sine to the negative 1 of 3 over root 13. Make sure you get that on your calculator. And we've got to get the same answer. I've made some dumb mistake. And voila, we do 56,31. You don't have to show all three, just one or the other. But the one we're going to use the most often in this section is to find an angle, we're going to use tan. Okay, so if I use the fact that tan theta is equal to 3 over 2, how do I find angle theta? I go shift tan to the negative 1 of 3 divided by 2. It's working out which angle will give you a ratio of the y coordinate over the x coordinate of 3 over 2. And the calculator tells you 56,31 degrees. Okay. All right. Okay. Last example. Okay. Okay, if I take this one over here, okay, we've got okay. So we're given it says you've got a point 12, 5. So this is your x coordinate, this is your y coordinates. And the question once again is evaluate tan alpha, cos alpha, and sine alpha. Remember, we could extend it and add billions of points. We could use any point along this time. We could use any point here, we could use a point here, and you could get those ratios, but we're just going to use the 1 point now. Okay, what's our stupid poem? Shade your rear. So sine, shade your rear. Why? Because x rays tan your exterior. Right. Okay. So in this question over here, evaluate tan alpha, cos alpha, and sine alpha. Okay. So the angle I'm given here, we're given it the name alpha. That is an arrow measured in an anti-clockwise direction. Okay. So tan alpha, okay, is going to be equal to the ratio of the y coordinate over the x coordinate. And a y coordinate and an x coordinate go together for that angle is 5 over 12. So that's fine, tan alpha. However, with cos alpha, we run into a problem. What's the problem? The definition of cos is the ratio of the x coordinate, okay, over here, okay, over the radius. And we don't have the radius from the center to the origin. So I've got to go figure out the radius. How do I figure out the radius? Well, I know that the radius squared is equal to x squared plus y squared. Okay, so in other words, the radius squared is going to be equal to 12 squared plus 5 squared. And if you go work that out, you'll see the radius squared is 169. So the radius is equal to the square root of 169. So the radius is equal to 13. So now I can go fill in that value. My radius is equal to 13. Okay, and now I can answer the question. And what is the question? Go work out cos of angle alpha. And cos of angle alpha then is, we know by definition, it's just the name of the ratio of the x coordinates over the radius. So in this case, it's going to be 12 over 13. Okay, right, that's cos alpha. And last of all, question C, what's sine of angle alpha? Well, sine of angle alpha is the ratio of the y coordinates over the radius anywhere along that line. Your y coordinates is 5, your radius is 13, so sine of alpha is going to be equal to 5 over 13, right? And question B says, determine alpha correct to 2 decimal digits. Okay, well, I'm just going to pick one ratio. Tan is usually the easiest to work with, so I'm going to use the fact that I know that tan of alpha is equal to 5 over 12, right? So how do I find the angle? Okay, remember alpha is an angle. You're going to go shift tan to the negative 1 of 5 divided by 12 equals, and you get 22,62 degrees. Okay, right. I'm just going to stop there because this is taking a lot longer than I thought. But the last thing I want you to do is on your own, I want you to try this. Okay, if I've got a point, okay, on the Cartesian plane, and let's make this point 4, 1, and let's call this angle over here angle beta. Okay, I want you to go figure out tan beta, sine beta, and cos beta. Okay, and then I want you to find the size of angle beta correct to 2 decimal digits. Okay, and that is your homework. Okay, and I'll go over that some at the beginning of your next lesson. Okay, there's no other work for you today. It was a long lesson. Okay, and I have pushed you. Okay, I'm challenging you a little bit. You are AP Math students. I do not want a million WhatsApp saying, I don't understand. Okay, guys, we pushed it. You, as I said, you're AP students. You are going to do trig again. Okay, in core math, this is really not a big part. You'll see the kind of questions you're going to get are going to be really easy. The key ideas I wanted you to get to today is, what is trig? Trig is about the naming of ratios. And on the Cartesian planes, okay, that we're using the fact that those ratios stay fixed. So on the Cartesian plane, your ratio of for a fixed angle of y over r is called cos. The ratio of y over x, y over r is called sine. Y over x is called tan. Okay, and x over r is called cos. And that those ratios stay fixed along that line. That's all. That's the key fundamental idea, okay, of trig. Okay, and it has all kinds of implications after that. It's been a long lesson. Okay, I hope you're in one piece. Okay, give that angle some a go, and good luck.